Imagine a home built faster, maybe cheaper, definitely more durably, using tech you probably associate with, I don't know, little desktop gadgets.
Yeah, it sounds kind of sci-fi, doesn't it?
It really does. And what if that same tech could help tackle the housing crisis and maybe even create new jobs?
Well, that's exactly what we're digging into today.
We are diving deep into the world of 3D printed homes, specifically how these big construction 3D printers are making affordable housing a reality.
Yeah, in communities that really need it. And for this deep dive, our insights are coming straight from Eman Hussein. He's the director of 3D printing at a company called Alquist. He shared a lot about their process.
Okay, great. So our mission today is really to unpack how this whole 3D home printing thing works, from the digital file to the actual house.
Right, understand the practical benefits, the pros and cons, and definitely tackle some of the maybe surprising stuff around it, especially, like you said, the workforce angle.
Okay, so let's set the scene first. What are these 3D printed homes we're talking about? You mentioned Alquist.
Yeah, Alquist. Their focus is on printing affordable single-family homes. We're talking maybe 1,300 to 1,500 square feet, typical family home size.
Right.
And their niche really is rural communities, places maybe underserved by traditional building methods. They're trying to provide solutions there.
That makes sense. So how does it work when they, show up on site?
Okay, so they usually start with a foundation that's already there, like a concrete slab or what's called a ribbon footing.
Uh-huh.
Then they basically set up this huge printer around where the house will be. Picture a big robotic arm kind of thing.
Okay.
The whole setup involves, well, the printer itself, obviously.
Yeah.
Then there's a control panel for all the settings. You've got a big silo holding the dry concrete mix.
Like a grain silo.
Sort of, yeah. And right under that, there's a system that mixes it with water very precisely and then pumps that wet concrete through a hose right to the printer nozzle.
Okay, so it's quite the setup. Now, this next part, you mentioned it's kind of like a desktop 3D printer. That helped me picture it.
Exactly. The core idea is similar. It all kicks off with a CAD file, that's computer-aided design.
Right, a digital blueprint.
Precisely, a super detailed digital blueprint for the whole house. And that file is essentially the brain guiding the whole operation.
So it tells the printer exactly what to do.
Absolutely. It dictates the precise path the nozzle takes, how fast it moves, exactly how much concrete to extrude, where, and when.
Wow.
The really key thing here is the precision and repeatability. You basically eliminate a lot of potential human error in building the core structure. And it opens up possibilities for, complex designs that might be super hard or costly to do the old-fashioned way. Think of the printer reading one thin slice of the house at a time.
Okay.
Following the nozzle's center line, and then just stacking those slices layer after layer after layer.
Okay, so you got the digital plan, the machine is ready, the printer starts actually building. How does it handle walls? And, the tricky bits like doors and windows.
Yeah, right. So for the walls, they often use this concept of printing two rails.
Ooh, rails.
Yeah, imagine two parallel lines of concrete being laid down at the same time, forming the inner and outer edges of the wall.
Okay, I think I follow.
And that space in the middle, it's left hollow or semi-hollow. It creates a built-in channel, which is perfect for running electrical wires and plumbing later on.
Ah, clever. So Alquist is kind of like the framing crew in a traditional build.
That's a great analogy, yeah. They build the main walls with the printer, then they work with the general contractor, the GC,
Right.
to guide them on installing the windows, the doors, HVAC plumbing, integrating those traditional trades into this new process.
That makes sense, that collaboration. But okay, what about those openings? Doors, windows. How does the printer just stop? And what holds up the wall above the gap?
Good question. It's actually pretty smart how it works. The software basically slices the house design into wall sections between openings. So if there's a doorway, the printer will finish the wall section on, say, the left side. Then the nozzle lifts up, moves across the gap, and starts printing the section on the right side.
Okay, so it builds around the openings.
Exactly. And once the walls get high enough, right up to the top edge of where a window or door will be,
Yeah.
they pause the printing briefly and manually place a steel lintel across the top of that opening.
A lintel, right? Like a strong beam.
Precisely. It's a pre-made support beam. Then the printer just continues printing right on top of that steel lintel, bonding the concrete to it.
Wow. Okay, so it's this mix of automation and manual intervention for specific parts.
Exactly. It shows how the tech isn't really about replacing everyone, but more about automating the repetitive stuff and using human skill where it's most needed, like for that integration.
It's kind of wild thinking about that concrete hardening fast enough for the next layer. You mentioned layers. How many were talking?
Yeah, it builds up quick. Typically, a house might have around, say, 150 layers or so.
Okay, and how thick is each layer?
Each one is about 3/4 of an inch thick, roughly. You stack enough of those up, and you get your standard, say, 9-foot wall height.
And the setting time? How long between layers?
That's crucial. They call it the layer set time. Based on their current concrete mix, it's about 5 to 10 minutes, just long enough for it to be firm enough to support the next layer without sagging.
5 to 10 minutes. Wow.
Yeah, but then for major loads, like putting the whole roof structure on, they'll typically wait about 2 weeks. That's pretty standard for concrete to gain significant strength.
Right, concrete needs time.
Yeah, it reaches its full design strength, usually around 28 days. Standard concrete behavior, really.
So you mentioned earlier you can get different looks, different aesthetics. How does that work? And what about the actual strength?
Yeah, the nozzle design itself plays a big role in the final look. You can have a squared-off nozzle, which gives you a very flat, smooth-looking wall surface.
Okay.
Or you can use a rounder nozzle, and that leaves more of a visible, kind of beaded look where you can really see the layers.
And structurally, any difference?
No, structurally they're the same. It's purely down to the aesthetic you want for the house.
But can you make the walls stronger if needed?
Oh, absolutely. If you needed, say, a more heavy-duty wall, maybe even for ballistic resistance or something extreme, you just adjust the print settings. You'd likely increase the nozzle thickness to lay down more concrete per layer, making the whole wall system much thicker and more robust.
Interesting. And how do they make sure these layers stick together properly? No gaps or weak spots?
Ah, yeah, they have a neat trick for that. On the back of the print nozzle, there's often a little raking system.
Raking?
Yeah, as the nozzle moves, this rake creates tiny grooves in the wet concrete layer it just put down.
Okay. Why?
Well, 2 reasons. One, it gives a visual check for the height, make sure everything's level. But more importantly, those grooves create a better surface area for the next layer to bond to. It helps the layers fuse together really strongly as they cure.
That's clever. So it sounds a bit like, I don't know, automated bricklaying in a way, layer by layer.
You could definitely draw that parallel. It is layer by layer. But obviously the material is totally different flowing concrete instead of individual bricks and mortar. And critically, the amount of manual labor involved in laying those layers is drastically reduced.
Right. So summing that up, what are the main takeaways? The big advantages compared to how we normally build?
Well, the big ones are pretty clear. Speed is huge. Construction time can be cut significantly.
Okay.
Cost is another major factor. Less labor time, potentially less material waste. It generally adds up to being less expensive.
Faster and cheaper. What else?
Durability.
Mm.
You're essentially building a solid concrete structure, which is inherently very strong and resilient over time, against weather, pests, that sort of thing.
Makes sense.
And there's one more benefit tied to that 2-rail or twin wall system we talked about. In traditional building, they sometimes call it double wythe construction. Because there's that gap or insulating material between the inner and outer concrete layers, the homes are considered thermally broken.
Thermally broken, meaning?
Meaning heat doesn't transfer easily from the outside wall to the inside wall, or vice versa. There's no direct bridge for the temperature.
Ah, so better insulation.
Exactly. It leads to significantly lower utility bills for the homeowner, less energy needed to heat the place in winter or cool it in summer. That's a huge long-term affordability win.
Okay, faster, cheaper, stronger, and more energy efficient. It sounds almost too good to be true. Which brings us to the question I know is on a lot of people's minds.
The jobs question.
Yeah, the jobs question. Automation like this. The immediate thought is, well, it's going to replace construction workers, right? Manual labor.
It's a really common concern and totally understandable. But Ayman Hussein from Alquist, he addresses this directly. And his perspective is interesting.
Okay.
He says Alquist sees this technology not as the cause of job losses, but actually as part of the answer to the existing national job shortage in construction.
Wait, the answer to the shortage?
Well, think about it. There's a well-documented shortage of skilled construction labor in many areas. This tech allows them to build more houses with potentially fewer on-site laborers, for the framing stage at least. But crucially, Alquist is really committed to local hiring.
What does that mean in practice?
It means when they go into a community to build, they actively hire people from that community. They train them to operate the printers, manage the system, become the local print crew.
So they're training locals on this new tech.
Exactly. He stressed that as an automation company, they feel it's their duty, their responsibility, to help replace any jobs that might be displaced down the line. So they're working with universities around the country
Oh, interesting.
to set up workforce development programs, training people specifically for the skills needed in this emerging 3D construction industry, creating new kinds of skilled jobs.
So it's less about eliminating jobs and more about transforming them and training people for those new roles.
That seems to be their philosophy, yeah. Reskilling and upskilling the local workforce to embrace the technology, not be replaced by it.
Okay, that's actually a really important perspective to hear. So let's try and wrap this up. We've seen how 3D printing is this fascinating mix of like digital precision meeting real-world construction.
Yeah, delivering homes that promise to be affordable, tough, energy efficient.
And, maybe counterintuitively, it seems to be a technology that's trying to proactively deal with the workforce changes it brings, rather than just letting jobs disappear.
Which leads us to maybe a final thought for you to chew on.
Okay.
If this technology can actually deliver homes faster, cheaper, more sustainably, and at the same time, it can create new kinds of skilled jobs by training local people, what does that really mean for the future? Like the future of construction itself, urban development, even how we think about manual labor when automation is becoming so capable. Think about the ripple effects, on local economies, supply chains, if this scales up like some people think it might.
Yeah, that's a lot to think about. Faster, cheaper, greener homes and new local jobs. If that's the promise, it could really change things.
Could be quite the shift.